Every day, countless people around the world wait for a life-saving phone call. They are waiting for a kidney transplant. Their own kidneys are failing, and they need a new one to survive. This wait can be incredibly long and difficult. Many patients must go through hours of dialysis several times a week. This process cleans their blood, doing the job their kidneys can no longer do. While dialysis keeps them alive, it is not a cure. The ultimate hope for these individuals is to receive a healthy kidney from a donor. It is a race against time where the number of people needing a kidney far outnumbers the organs available. The biggest hurdle in this race is finding a compatible match. Your body has a powerful defense system, your immune system, which protects you from foreign invaders like germs. Unfortunately, it can also see a new organ from another person as an invader. One of the most important factors for a match is blood type. A patient with blood type O, for instance, can typically only receive a kidney from a donor who also has type O blood. This significantly shrinks the pool of potential donors for them, making their wait even longer and more uncertain. This is the central challenge that transplant medicine has been trying to solve for decades. This scarcity creates a desperate situation. For ethnic minority groups, the problem is even more severe. They often have higher rates of kidney disease and are more likely to have rarer blood types, like B. This means their wait for a compatible organ can be disproportionately longer than for other groups. The statistics are sobering. Many people die while still on the waiting list. They run out of time before a suitable organ can be found. This is the heartbreaking reality that doctors and scientists are working tirelessly to change. They are searching for innovative ways to bridge this gap between supply and demand. The emotional and physical toll on patients and their families is immense. Imagine living with the constant uncertainty, your life revolving around treatment schedules, and the hope of a phone call that may never come. The search for a solution is not just a scientific pursuit, it is a deeply human one. It is about giving people back their lives, their freedom, and their future. The need for a breakthrough has never been greater. We need a way to make more organs available to more people, regardless of their blood type, and to shorten the agonizing wait that defines so many lives. Now, imagine if we could change an organ's blood type. This sounds like science fiction, but it is now becoming a scientific fact. Researchers have discovered a remarkable new technique. They are using special molecules called enzymes to change the blood type of a donor kidney. Specifically, they have found a way to turn a kidney with blood type A into a universal donor O type. This is a monumental step forward. It opens up the possibility that a kidney from a type A donor could one day be given to a patient with any blood type, including O, B, or A. This could dramatically expand the number of available organs. Let me explain how this works in simple terms. Your blood type is determined by tiny sugar molecules called antigens that sit on the surface of your red blood cells. Type A blood has A antigens and type B has B antigens. Type O blood has neither. These antigens are also present on the cells of your organs. If you give a type A kidney to a type B patient, the patient's immune system will see the A antigens as foreign and attack the new organ. This is called rejection, and it is very dangerous. The new research uses an enzyme that acts like a pair of molecular scissors. This special enzyme, taken from bacteria, is designed to find and snip off the A antigens from the surface of the kidney's blood vessels. The scientists take the donor kidney, which is not yet in a patient, and flush it with a solution containing these enzymes. Over a few hours, the enzymes get to work, effectively stripping the kidney of its blood type A markers. What is left is a kidney that looks like a type O organ to the recipient's body. It becomes a universal organ, a blank slate that is less likely to be recognized as foreign and attacked by the immune system of a non-A recipient. The concept is brilliantly simple, yet incredibly powerful. By removing the very markers that cause incompatibility, we can make organs more universal. This technique could be a game changer. It means that a kidney that might have been discarded because a suitable type A recipient could not be found could instead be used to save the life of a type O or type B patient who has been waiting for years. It is about maximizing every precious gift of donation and making sure that no organ goes to waste. This innovative approach could fundamentally alter the rules of organ matching. A bold idea like this needs to be tested safely. Scientists could not simply place this altered kidney into a living patient right away. Instead, they used a unique and ethical method to see if it would work. They connected the newly altered kidney to the circulatory system of a brain-dead patient. This patient's body was being kept functioning by a ventilator, but their brain had ceased to work. This generous donation to science allowed researchers to study how a human body would react to the organ in a real-world setting without putting a living person at risk. It was a crucial and respectful step in the research process. For a few hours, the type O blood of the brain-dead patient was pumped through the blood vessels of the kidney that had been converted from type A. The scientists watched very closely. They were looking for any signs of hyperacute rejection, which is a rapid and violent immune attack that can destroy a mismatched organ within minutes or hours. They performed biopsies, taking tiny samples of the kidney tissue every hour. They analyzed these samples under a microscope and ran tests to see if the patient's immune system was launching an assault against the new organ. This was the moment of truth for the entire experiment. The results were astonishing and provided a huge sense of relief. The kidney was not rejected. The patient's body did not attack the organ. The biopsies showed no signs of damage that would normally be seen with an incompatible transplant. The kidney continued to function, filtering the blood and even producing urine, just as a healthy kidney should. It behaved exactly like a compatible type O kidney would have. This demonstrated first time in a human model that the enzyme treatment was successful. The molecular disguise had worked, fooling the immune system into accepting the organ. This experiment was a critical proof of concept. While it was a short-term study, it provided the essential evidence that this technique is not just a theory, but a practical possibility. It showed that removing the blood-type antigens from the organ prevents the immediate catastrophic rejection that doctors fear most. It gave the scientific community the green light to continue this research and to start planning for the first clinical trials in living patients. This was a pivotal moment, moving a brilliant idea from the laboratory one giant step closer to the hospital bedside. So, what does this all mean for the people on the waiting list? The implications are truly profound. For patients with blood type O, who have the hardest time finding a match, this could be life-changing. They are considered universal donors for blood, but are universal recipients only for other type O organs. Because type O is the most common blood type, the demand for type O kidneys is incredibly high. This new technique could effectively increase the supply of kidneys available to them by allowing them to receive organs from type A donors. The wait time for these patients could be dramatically reduced. This breakthrough could also have a major impact on health equity. As I mentioned, patients from ethnic minority backgrounds often wait longer for transplants, partly due to the distribution of blood types. For example, making type A kidneys available to type B patients, who are more common in some ethnic groups, could help level the playing field. It makes the organ allocation system fairer and more efficient. It is about using science to break down biological barriers that have created disparities in healthcare. Every organ that can be made universally compatible is another life that can be saved. While we are still in the early stages, the path forward is clear. The next step will be to conduct clinical trials with living patients. Scientists will need to ensure the long-term safety and effectiveness of this procedure. They will monitor patients to see how these altered kidneys function over months and years. But the initial results have filled the medical community with incredible optimism. This research is not just about kidneys. The same principle could potentially be applied to other organs, like hearts, lungs, and livers, further revolutionizing the entire field of transplantation. This is more than just an interesting scientific discovery. It is a beacon of hope. For the millions of people whose lives are on hold, waiting for an organ, this research signals a future where the wait may not be so long. It is a future where a person's blood type may no longer be a barrier to receiving a second chance at life. Medicine is about pushing the boundaries of what is possible to improve and save lives. This remarkable breakthrough is a perfect example of that mission in action, promising a brighter and healthier future for transplant patients everywhere.